So we've seen how JavaScript, the engine, is wrapping our executing code in an execution context. But there's an important aspect, one of those weirder parts of JavaScript, that we need to understand. And to understand it, we just need to dig a bit more into what the JavaScript engine does to create an execution context. So this is the execution context, creation and hoisting. To start with, let's look at a phenomenon that happens in JavaScript that people find surprising and perhaps a bit confusing. I have my simple variable here, a, and my function b. I'm going to actually put a line of code in here just so the function does something. I'm going to use console.log. This writes to that console in the tool window in the DevTools in the browser. If you haven't used this before, we'll be using this an awful lot throughout this course. It's just going to output whatever we put in here out to that DevTools window. So when we see called b, we'll know that we called this function. Now, if I was to call the b function, if I was to invoke it to execute it, you would normally think I would do this. And I can console.log a after that. So what would you expect to see? Well, I would expect to see called b and then hello world. All right, so let's go ahead and execute this. We'll run it in the browser, hit F12 for my DevTools, and look, exactly what we expected. Now let's do something a little different that in other programming languages you would expect to not work at all. I'll go ahead and go back to brackets, and I'm going to move these calls where I invoke the b function and where I output the value of a to the top of the page. I'll save this. Now what would you expect to have happen? Well, in most programming languages you would expect an error because programming languages execute their code one line at a time, and since we haven't gotten to the b function, I can't use it yet. That's what you would normally expect. But JavaScript isn't like that. When I go back and refresh this page to rerun the JavaScript, look what happens. It ran the function, and instead of throwing an error, it gave me a value, but not the hello world value that I saved, but this thing called undefined. So even though the function was below where it was executed, it still ran. And in fact, this a variable was available to me, even though it wasn't the proper value. Watch what happens if I just remove it outright. So I'm trying to console.log a, and I don't have it declared as a variable anywhere. Now, I actually get an error. A is not defined. But if I put it back, so that somewhere on this JavaScript file I have that a variable declared, instead of an error, I get a value, the phrase undefined. This phenomenon is called hoisting. But the way it's explained, I think, can give you the wrong impression. The way, if you look online, that hoisting is explained is that people say, well, that variables and functions in JavaScript are hoisted or moved to the top by the JavaScript engine as if they were moved physically up to the top so that they work, no matter where you put them. But we can tell that that's not quite right because a wasn't set to hello world, so it wasn't like this line was physically moved. It behaves a bit more like this, as if I had a variable declared and then set the value later. But still, that's really not what's happening, because we already said what's executing isn't what you've written. It's being translated by the JavaScript engine. So it's not like the JavaScript engine is physically moving the code that you've typed around and then executed it. So let's undo all this. Here's the code that we wrote. To understand what JavaScript is doing, we just need to dig a little bit deeper into the execution context and how it's created. The reason JavaScript behaves the way it does, that variables and functions are to some degree available even though they're written later in the code is because the execution context is created in two phases. The first phase is called the creation phase. In that phase, we know we have the global object, which is set up and in memory. We have this, which is set up and in memory. And again, the global object only referring to when we're dealing with the global execution context. We'll see other execution contexts later. But this is always created inside an execution context. There's an outer environment that's created. And in that creation phase, as the parser runs through your code and begins to set up what you've written for translation, it recognizes where you've created variables and where you've created functions. And so it sets up, in this creation phase, the memory space for the variables and functions. And it's that step that is somewhat confusingly called hoisting. It's not actually moving code to the top of the page. All this means is that before your code begins to be executed line by line, the JavaScript engine has already set aside memory space for the variables that you've created in that entire code that you've built and all of the functions that you've created as well. So those functions and those variables exist in memory. So when the code begins to execute line by line, it can access them. However, when it comes to variables, it's a little bit different. You see, the function in its entirety is placed into memory space, meaning that the function, its name, and the code inside the function that's being executed. However, the next phase, the execution phase, which we'll talk about in a moment, where it actually executes your code line by line, that's when these kind of assignments are set, where A equals something. So the JavaScript engine, when it sets up the memory space for A, it doesn't know what its value will ultimately end up being until it starts executing this code. So instead, it puts a placeholder called undefined. That placeholder means, oh, I don't know what this value is yet. That's the same placeholder that we would have if we never set it at all. All variables in JavaScript are initially set to undefined, and functions are sitting in memory in their entirety. That's why it's actually a bad idea to rely on hoisting in any way. You can run into trouble when you realize that that value is actually undefined and not the value you're expecting. So while this technically kind of works, it's better to always do this so that you don't get caught up in that trap. Now, that said, we understand that when we're talking about hoisting, when we're talking about this scenario where I can call the function even though it's declared later, it really has to do with the fact that what I wrote is not what's directly being executed, but the JavaScript engine is then taking my code and making decisions. In this first phase of creating the execution context, the wrapper around my code being executed, it's going to set up the memory space for the functions and the variables that it sees that are going to be used when it starts executing the code. And therefore, we have access to them in a limited way before they actually physically appear on the page inside that lexical environment. Kind of weird, right? But not so much when you understand that it's just phase one. I'm going to set up the memory space. So when the code begins executing, those things are actually already sitting in memory because it looked at your code and already preset things up to be ready for the code to start executing.